This is the lecture over Chapter 7 of your textbook entitled File Handling and Applications. In this chapter, we're going to talk a little bit about computer files, the different types, how they're stored, etc. We'll talk about something called the data hierarchy, which is just grouping of information. We'll talk about what file operations are, reading and writing files, creating files, etc. We'll talk about something called control break logic and control break reports. We'll talk about merging files. We'll talk about processing files as master and transaction files. And then we'll talk about what it means to have random access files. So first of all, what is a computer file? You've probably worked with files on your computer and not thought a whole lot about it. But first of all, it's a collection of data, for example, a Word document, a basic program, etc. And it's stored on permanent storage devices, also sometimes referred to as non-volatile devices in other computer classes. Basically, what permanent storage devices do is they store files, and if you remove power from the storage system and then reapply power, the data is still there, so it persists. Examples of this would be computer hard drive, flash drives, storing it, quote, in the cloud, burning it to DVDs or CDs, USB thumb drives, or magnetic tape. Sometimes files are classified as to whether they are text or binary. A text file contains things that we can read. We can take it into a text editor, might be a basic program, might be an email, etc. Binary files are files that you cannot just pull into the text editor and figure out what their contents are. Microsoft Word documents, for example. They're binary files. You have to have Microsoft Word to decode those files and display your document to. Pictures are binary files, music are binary files, etc. Now, I have a little bit of issue here with the last bullet point on this slide, talking about file size. First of all, a byte is 8 bits. A bit is a 0 or a 1 that the computer processes. 8 of those are grouped together into a byte. They say those can represent one character. Well, as long as you're not doing Unicode or something, yes, that is true. A kilobyte is actually 1,024 bytes. A megabyte is 1,024 kilobytes. A gigabyte is 1,024 megabytes. A terabyte is 1,024 gigabytes. These days we're starting to use petabytes. A petabyte is 1,024 terabytes. Now, they did everything like thousands, millions, billions, trillions, etc. That's a close approximation, but actually, like I pointed out, those should be multiples of 1,024. Here, we're looking at File Explorer on a Windows machine. There's a lot of information here, but in the lower right-hand corner is the actual files that are in this directory. The directory we're in, you can see here, computer, local disk, which is our C drive, into a folder called sample files, and then sample files has a picture, class notes, high and low cells.java, so a Java file. Notice over here under type, it tells us the picture's a PNG. Class notes is a text document, and this Java program, of course, is a Java file. Another thing we have is the size of the file. This is how much space on the hard drive it's taking up. And right here in this column, we have date modified. So that's going to tell us the date and time that the file was last changed. Most modern operating systems, if not all modern operating systems, have what's called hierarchical file systems. A hierarchical file system is a set of directories that look like an upside down tree. Every file system object has a parent, but a folder can have multiple files and other subdirectories underneath it. Here we have an example of a Windows path. We start at the C drive. We go into a directory called logic. From there, we go into a subdirectory called sample files, and in that directory, there is a file called payrolldata.dat. So that's a full path name starting at a drive letter, walking through the hierarchical file system to get to a specific file or folder. The data hierarchy refers, this is kind of an abstraction. We have characters. These are letters, numbers, and special symbols. We have what's called fields. Fields are items that represent a single attribute. So it might be, if we go back to that directory listing, the fields were the name of the file, the size of the file, the date, time, modified, etc. If you group all those together, like for example, one line out of that listing, we would refer that to as a record. A record talks about one item. It may have multiple fields that describe that one record. And if we take a whole bunch of related records and put them in a file, then we have a file that has records stored in it. So that's all the data hierarchy is some definitions. Now then, one of the things after we go over this chapter that we will do, at least on occasion in our program, is read and write files. And all programming languages have a way to access files, reading and writing them, and possibly other things as well. So one of the first things you have to do is declare a file identifier. And you can either say it's an input file, which means we're going to read data from it, or an output file that means we're going to write data to it. That file identifier is basically an abstraction. Once we declare a file identifier, and then we open a file and associate it with that file identifier, all the reading and writing and accessing of the file is going to take place through the file identifier. In the middle of the screen, you'll see that we have an open statement. It says, I want to open on the file identifier employee data, an actual file on my system called employeedata.dat. Since we didn't give a full path name to that file, it's going to assume it's in the same directory as the program. Reading data from a file, if we read from the user, we use the input statement. Reading from a file, we're also going to use the input statement. And what we're going to do is we're going to say input a variable that we want to hold the information that we read, and then we're going to have new keyword or a new syntax called from file identifier. So what this is going to do is presumably read a line from employee data, which is really employeedata.dat, and read that first line into name, the second line into address, and the third line into employee data. So that's how we get input or information from a file as opposed to getting it from the user, which we've been doing to this point. We talked about records and fields. What we're seeing here is kind of a picture of that data hierarchy. We have a file. That file has 4 lines. Each of those lines we're going to refer to as a record. Those record is going to have information related to a number of fields. In this case, it's shown to use a comma delimiter. And the first field is going to be name. The second field is going to be address. And the third field is going to be pay rate. And then obviously name, address, and pay rate are made up of characters, either alphabetic or numeric characters, depending upon what is appropriate. This information is stored in a file, and when we read it, it's going to read it into memory, more particular variables of our program that reside somewhere in memory. So we're reading from a storage device into memory when we're reading. A sequential file is a file that has to be read from the beginning to the end, processing one record at a time, as opposed to a random access file, which we may or may not talk about, where you can just go in and say, give me the 5th line, go to the end of the file, go 20 characters into the file, etc. You do not have to read through those in order. We'll talk about sorting now. Right now they're worried about sorting records, and that sorting would be done upon a specific field or set of fields. Different types of sorting. If we sort something numeric, then it would be in numeric order. If we sorted it alphabetical, it would be in what I call dictionary order. The strings would appear in the same order that you would find them if they were placed in a dictionary. A lot of times we read data from a file, we do some processing, and then we need to write data out to another file. So here they're showing us how to do an output. If we say output and a list of strings or variables, it's going to write it to the user. But notice at the end of the statement we say to employee data. So what it's going to do is it's going to write it to whatever file has been associated with the file identifier employee data. We open a file, we read or write it, and then when we're done with it, as soon as we're done with it, we should close that file to let the operating system know that we no longer need to or intend to interact with that file. So here's a flow chart that uses files. I think this is one that we've seen before, talking about finding somebody's pay rate and giving them a raise. It looks like it's a $2 an hour raise up in the declarations. So in addition to declaring strings for the name and address and a numeric value for pay rate, which we're going to read, and then having a constant called raise, which is the amount. So in this case, I don't know how realistic this is, but it appears that every employee of this company is going to get a $2 raise. So in the housekeeping, we open the employee data file, which is going to have their current information. We open a second file called updated data, which we're going to write the new information, in particular with the new pay raise. And then we need to prime our loop. So what we're going to do is we're going to read the first name, address, and pay rate from the employee data file. Then what we do, this is very common with doing file I/O, the condition we want to check is while not at end of file. And you'll see this in an upcoming programming assignment. But while we're not at end of file, we want to go to the detailed loop, which is going to process one employee or one record. Then we'll go back and say, okay, are we at end of file? Yes. Then we finish up. No. We go through the detailed loop again. I'm going to jump over to the bottom left on the finish. Once we're done, we just need to close the old employee data file. We need to close the updated data file, and then we're done. So that's just cleaning up when we're done. Now, most of the work is going to happen in the detail loop. That's usually the case. So what we're going to do is we're going to say their pay rate is whatever the pay rate is we just read, plus whatever is stored in the constant raise, which is $2. Then what we're going to do is we're going to turn around and we're going to output their name, address, and new pay rate to the file associated with file identifier updated data. Some programming languages, I'm finding it hard not to say file handles. A lot of programming languages use file handles as the same thing as file identifier. So if I ever slip up and say file handle, you'll know what I'm talking about. Once we've processed that employee, we need to turn around and read the next data from the file that we are processing. So they've highlighted the things that are related to file I/O, things that we hadn't seen before: opening the file, closing the file, declaring input and output files, and reading from and writing to file identifiers. This is the pseudocode that for the exact same thing. I'm not going to go over it line by line because, if you understood what we were doing in the flow chart, you should understand what's going on in the pseudocode. A lot of times what you do is you keep a backup file. That is, you have a file you're going to alter, especially if you're doing this for the first time and there's some possibility that there's a logic error and you might corrupt the data. A lot of times before you start processing a file, you create a backup copy, and they like to use the terminology that backup copy is now called a parent file, and the new file is called a child file, and the child file is what you update. Again, if something goes really bad and you need to go back and start over again, you would then restore the backup file that you made. One thing we're going to talk about is control break and control break programs. Basically, a control break, they say, is a temporary detour of logic. Basically, another way to say that is some condition becomes true and you want to jump off and do something and then come back to the normal flow. That's just another way to word that. So what happens is we use a value called the control break value to determine when some special action should occur. So I don't remember what example they're going to use here, but right now let's just say zip code. So if you have a file that is sorted by zip code, we're going to process somebody in the same zip code. When we see a new zip code, we're going to jump off and do something like, for example, output a count of how many people lived in that zip code. We're then going to come back to the main logic of the program and process all the people that are in the next zip code, whatever that might happen to be. If we do that over and over again, we have some data and then a summary, then some data and a summary, for example. That is called a control break report. It's grouping things that are related, in this case, in my example, in the same zip code. The one thing for this to work correctly is the input records must be in sequential order, and they don't say this, but in sequential order based upon the field that you're using as the controlled break. For example, in my case, zip code. This file would have to be sorted so that all the records were in numeric order based on zip code. So here is an example, and what they're doing is they're using the state to perform the control break on. So it's in alphabetical order, so you start out with people in Alabama. So as long as you're reading people from Alabama, you're simply going to write out their name, their city, and their state. Read somebody else from Alabama, write out their name, city, and state. Now, when you hit something that's not Alabama, for example, Alaska, so your control break value changed from Alabama to Alaska. What you're going to do is you're going to jump off somewhere else in your program, possibly to another module, and say, okay, I saw 3 people. The count for Alabama is 3. I'm now going to set that count back to 0, and now I'm going to process all the people from Alaska, in this example 5, and then Arizona, in this example 1. So this is an example of control break logic and a control break report. So here's some examples of other things that would be considered control break reports. If you listed all the employees and you ordered on their department number, and every time you saw a new department number, you would say go to the next page. That way you have one department per page. If you worked at a bookstore and you had a list of all the books that were on sale and they had a category, you could then say for each category, here's the books and how many books we have on sale in that category. Here's another category. And at the end, this is how many books we have for sale in that category. The third example they have is we want to do some type of sales report, and we want a different color ink or a different color text for each new month. So you would go through and write January, let's say, in black. And then when you got to February, you would change the color of the text to blue. When you got to March, maybe you would change it to red, etc. So that it would be real easy to look at this report and see where January, February, March, etc., the information associated with those months. What we've been talking about here is referred to as a single level control break. That is, we're making our decisions and doing the control break based upon a single field or a single value. Okay, here's the one for doing something by state. So what happens is, while we don't have the end of file, we're going to use produce report. And then we have the pseudocode down at the bottom that matches up with this. So going to the next slide, you'll see that produce report goes through and saying, is the state I just read not equal to the previous state I read? So you would have old state that's going through, and for example, while we're in Alabama, it would be set to Alabama. When we get to the point that it says Alaska not equal to Alabama, that's true, so we jump over and do our control break. And what our control break does in this case is it prints out the string count4, tells what state, and then gives a number. Since we're processing a new state, it needs to set the count equal to 0, and we're now processing Alaska, so it needs to set old state equal to whatever state we just encountered, which in this case is Alaska. So it would go through and do that. Now, if we don't do the control break, that is, we're still in the same state, we just simply output the person's name, city, and state, and we need to increment the count by 1 to say, hey, we have one more person from that state. Then we would read the next record from in file and continue on with processing. The one thing you need to remember is when you hit the end of the file, you're processing some state, let's say Wyoming, and what you need to do is you need to print out the count for Wyoming and whatever that is. So if you don't catch that at the very end, you may miss one section of your report. And then now we're done with in file. The way we close it is just simply say close space and the file handle ID, which is in file. Another thing that you might want to do is merging a file. If you have files that are in order, either numeric order or alphabetic order on a field, and you have 2 of them, and you would like to merge the 2 together. So let's say you're some type of store, you have your customers, and they're in alphabetical order by last name. You happen to purchase another store. They also have a sequential file that has their customers in alphabetical order by last name. What you would then like to do is go through and create one big file that is a merged copy of those 2 sets of customers. And you can do that with merging a file. They give you a couple more examples down here. You hired a whole bunch of new employees. They're in ID number order, and you want to merge them in with your current IDs of your current employees, and have all those still end up in numeric order. And there's an example related to parts. For this to work correctly, each file has to have the same layout, the same fields in the same order. You have to be picking a particular field. Obviously, both files need to have that field, like employee ID number. And they have to be sorted. Ascending order is lowest to highest. Descending order is highest to lowest. I would say ascending order is probably the most common, so we'll use that. But they have to be sorted in the same order. So here they have 2 files, an East Coast and a West Coast file. It looks like you have a person's last name and then what the balance on their account is. And what we would like to do is go through and merge those so that the new merged customer file has all the customers in alphabetical order and then has their correct merged balance listed. So what we're going to do is we are now working with 2 files. Up to this point, we've read 1 file at a time. In this case, we have to be reading 2 or possibly more files, but we'll keep it easy for now. What happens is, as you're going through and reading, you need to determine when you hit the end of the file. Now, if you're going through merging and you hit the end of file on file 1, then simply you can just write the rest of file 2. to the result file, and then that way you don't lose any data. What we need to do is we need to declare our input files, and then what we do is we read the first record from each file. Then what we do is we go through and say, if we're doing this in ascending order, I have a record from each file. Which file value needs to be written out? Which one is less? If we call our files file 1 and file 2, if we write out the record from file 1 because it is less than the current record we're looking at file 2, we then need to read the next line of file 1 and then compare that to the line we had read previously from file 2. We go through and do that until we've gone through and merged the entire file. So this is going through, and we have a read east and a read west that will read a line from the file as long as we're not at the end of the file. If the names are, if we're at the end on both files, then we need to terminate. Merge records is the thing that actually goes through and does the merging. I'm trying to find, it doesn't look like they have that in the flowchart. Okay, here it is. So they go back and show you part of the flowchart, part of the pseudocode, and then they get down to the heart of this. Merge records. Is the east name less than the west name? If so, write that name out to the merged file, and then go back, and they don't say it yet, but read the next value from the east file. The opposite of that is the west file is less than. If that's the case, we write out the current information from the west name to the merged file. So we go through, and this is what actually is the important part of merging these records. So now they've shown you, if you output a record from one of them, you need to go back and read a new record to consider for merging. So this finishes off the sort. So what happens is you go to check end, which is going to see if you're done. Once both of those files are at the end, you would go to finish up. You would close the east file, you would close the west file, and you would close the newly created merged file. Another type of processing is something called transaction processing or batch processing. So what happens is you have something called the master file, which is considered the file of authority, that is the correct information. You have a transaction file that has information about updates we want to do to the master file. At some point, whenever we're ready, or maybe this happens at 11:59 p.m. every night, the transaction file is read, and whatever updates are listed in the transaction file are actually made to the master file. And that's referred to as updating the master file. And then, in my scenario, the next day you would start a new transaction file. And changes throughout the day would be stored to the transaction file. Again, tomorrow at 11:59 p.m., the master file would be updated. So here's some examples. Library has a file of all patrons, and then the transaction file has information about each book or other items checked out. Probably a more realistic scenario is the master file has the patrons and the books they currently have checked out, and then the transaction file would be either checking books back in or checking additional books out and updating that master file. The middle example, a college has a master file of all students, and then they have a transaction file for each course registration. As it processes the transaction file, it would look at the course registrations and update the master file. Another example is telephone company has a master file of every telephone number, and the transaction file would have information about calls that were made over some time frame. And then we'll go through and update the master file. Maybe it's counting how many minutes you used on your cell phone. So it would look at all the transactions for a given period of time and update the master record. There's a couple of scenarios that you can use as far as updating. You can apply the updates straight to the master file. The problem with that is if something goes horribly wrong, you may have to go to backup. You may lose some information if you don't have a current backup. Probably a better way is, especially in a scenario where you're running, once a day or once every 4 hours, whatever the case is take the master file and make a backup. Maybe name the master file whatever the name of the master file is, and then put date and time somehow encoded into part of the file name. So that way you have backups of each day or each time frame that you could go back if you need to look at some historic data, or again if something goes horribly wrong and destroys or corrupts your master file. You have the same condition that the fields need to be in the same order. So this is going to look a little bit like merging. We're going to read the files and then update records until we're at the end of both files. And then the read transaction is just going to read the transaction. Reading the master file is just going to read a record from the master file. And we're basically going to go through and update them. This is the pseudocode for what they've talked about so far in the flow chart. Now then, the heart of this is update records. So if we have a customer number that matches the master customer number, that means we're looking at the same person in both the update and the transaction file. What happens is the master total would be equal to whatever the master total currently is, plus whatever the transaction amount is that we're reading associated to the customer. Otherwise, one of them is less than the other. Whichever one is less than would be written out. They're actually doing a little logging. Notice that it says no master record for transaction blah. Telling you what's going on, or we updated the total. And then whichever file we processed, we would need to go back and either read from the transaction file or read from the master file when we processed one of those records. So here's an example. We have customers with their total. We have 4 transactions from 4 different customers in different amounts. So what happens is we would want to go through, and for the first line, customer number 100 would be equal to 100. So their new total for customer 100 becomes $1,400. 102, 103 didn't have any changes. We would need to update 105, etc. So we would just go through using the logic. Once we finish doing all the updating, we need to close the master file, the transaction file, and the new updated file. Another way to classify access to files is by what type of timeliness do we need to read them. So if we want to make changes in real time, we would refer to our application as a real-time application. When somebody says, I want to read this person's total, I want to add $400 to it and write it back into a database, for example, that's real-time processing. Batch processing basically is kind of like the update process. We have a batch of data, and we say at some point in time, take this data and batch process it and update the master file. An interactive program is where a user is sitting there, and as they type, they are reading, writing, changing values from the file. We talked about sequential access before, and I believe I mentioned random access. Random access basically means you can access the data in any particular order. or another way to say that is you can go directly to the record that you're looking for. Files that allow random access are known also as direct access files. This is a picture. In the first one, if we want to get to the record that's in gray, we have to read records 1, 2, 3, 4 to get to record 5. But in the second case, if we have direct access, we can say, give me record 5. And it would just go pull that value out of the file. We would not have to read or process the 4 values in front of it. So that finishes up the chapter.